All right, here's the Unit 5 review for Algebra 2. We're given the formulas. You'll be given these formulas for the test. You just got to understand how to use them. We got, for 1, 2, 3, 4, 5, we're going to have different formats of our quadratic, and we need to be able to graph it and talk about all of our characteristics of it. Starting with this is in vertex form. Let's just remember vertex form. It's going to be y equals a times x minus h squared plus k. We should know that the vertex will be at h comma k. A will tell us if we open up or down. All right, so I see this a is negative, so that means I'm going to open downwards. That's the same as concavity, concave up or concave down. Okay, the vertex, you can think about transformations. I take y equals x squared. Inside the parentheses, plus 3 would mean I'm shifting to the left 3, and then plus 4. You can also say, okay, hk, x minus h, well, it's going to have to be x minus negative 3. So that h is negative 3, the k is normal, it's 4, so the vertex is at negative 3, 4. Since I'm opening up, since I'm opening down, I'm concave down, I'm going to have a max at this negative 3, 4. Okay, I'm opening down, I know I have a max. The max is going to be y equals 4. The axis of symmetry is a line that cuts this in half. We can see that the axis of symmetry for a y equals x squared is always going to be a vertical equation. A vertical equation passes through the x axis. All of the x coordinates are the same. It'll be the x coordinate of your vertex. The domain for all quadratics, you can plug in any x. We can say it's all reals. We can say it's any x from negative infinity to infinity. We can say that, all different things. The range, well, it'll be all the y values less than 4 or equal to 4. Let's go ahead and graph the equation, make sure we have a couple points. Remember, you can go to trace and find the y-intercept when x is 0. You can plug in a couple points. Maybe negative 1 will give us a whole number. Yep, negative 1, 2. We know that quadratics are symmetrical, so I'm going 2 over to 2. I can go 2 over to negative 5. Negative 2. You can kind of do that as well. And we can kind of sketch our quadratic. And we can see my range is all my y's less than or equal to 4. Notice it's less than 4. These are all the y's that are being used for all these points. Okay, so there's vertex form. Here's an equation in standard form. Standard form, don't worry about the f of x. You can just think about it as a y, but you know, it's just a different form. It's got ax squared plus bx plus c. All right, and again, A is consistent for all of our forms. A is telling us if we're opening up or down based on if it's positive or negative. It'll tell us if we're skinny or not skinny. Here, A is positive. There's a 1 here, so we are concave up. Now, the vertex, we're going to have to find the axis of symmetry first. Okay, the only way I can find the vertex for this without using my calculator is to go the opposite of B over 2A. Okay, so remember the important equation was x equals negative b over 2a, and that was like h in terms of our vertex. So the opposite of b is what I'm thinking about, not negative b. So b is negative 4. Opposite of b is positive 4. 2 times a is 2 times 1. So the x coordinate is 2. Now this is very important for just all situations with equations, these two-dimensional equations. If you have 1/2, you can find the other half by substituting in and solving. So coming up here, a y coordinate for my vertex equals whatever we get when we plug in 2 for x. And I get 4 minus 8 plus 6. 4 minus 8 plus 6. So that's negative 4 plus 6, which is 2. So I should get 2, 2. Now, another way to do this is using your calculator. And you should obviously always be checking your work that's done by hand. You get x squared minus 4x plus 6. And graph. You already found that when x is 2, I have my axis of symmetry. I could have just plugged in 2 into trace, and I see 2, 2. We can see visually that this is going to be a min because we're opening upwards. We were asked for the y-intercept. The y-intercept occurs when x is 0. So plug in 0 for x. I get 6. If I plugged in 0, I get 0 squared minus 4 times 0 plus 6, so 0, 6. A point symmetric to the y-intercept. That's a good question. So if I have 0, 6, and that's 2 away from my vertex, understanding I have an axis of symmetry through x equals 2, then I got to go 2 over to the right, and I get 4, 6. Okay, so I got 2, 2, 0, 6. Since I know I have an axis of symmetry passing through x equals 2, the symmetrical point will be 2 over here, 4, 6. And then, with those 3 points, you can sketch your quadratic. Domain is all reals, infinity to negative infinity, or negative infinity to infinity. The range will be all my y's. All these points have y's that are bigger than or equal to 2. All right, another ax squared plus bx plus c. A tells us if we're opening up or down. Since A is negative, we are opening down. Our vertex, I'm going to skip. I'm going to go to the axis of symmetry. That is the x-coordinate of my vertex. That's opposite of B over 2A. And that's H, the x-coordinate of my vertex. So the opposite of B would be positive 12 over 2 times A. That's 2 times negative 2. So that's 12 over negative 4. So that's negative 3. Okay, now combining this to find my vertex, you can plug in negative 3 back into this equation. Again, if you wanted to, you can go and in your calculator, and you'll have the use of your calculator, graph the equation, negative 2x squared minus 12x minus 3. And say when x is negative 3, what is my y? We can find my y is 15, and we can see, I see we're up at 15. Why don't we adjust our window? Go up to like 17. That way we can see everything, okay? We can see that through x equals negative 3, there is my vertex. The y coordinate is 15. So negative 3, 15. I would have gotten the same value if I just plugged it in by hand. Y equals negative 2 times negative 3 squared minus 12 times negative 3 minus 3. And that's negative 18 plus 36 minus 3. And I would have gotten 15. The y-intercept when x is 0. If I plugged in x equals 0, you get negative 3. So 0, negative 3. You can also either just plug it in, you get 0 minus 3. That's negative 3 in your calculator with trace 0, negative 3. So the max or min at what value? Well, it's going to be a max. We can see since we're opening down, it's a max at y equals 15. We can plot that point, negative 3, 15. 0, negative 3. That's 1 point. So I'd go to negative 6, negative 3 as well. There's my point symmetric to the y-intercept. And this is, a good sketch of my quadratic. And the domain is all reals, and the range will be all my y's. Below, all these points on this graph is below, but equal to 15. All right, now we got intercept form. Intercept form is A, and then we like to say it's like x minus p. and x minus q, where x equals p and q are x-intercepts. Okay? It's the values that would make our y's 0. Positive p, positive q in this case. But just be careful with this plus and this minus. We'll talk about it. Okay, concave up or concave down. Since a is positive, a is a half. So a is bigger than 0. We're going to open up. Our intercepts, this is the important part, when x is not 6, but negative 6, because negative 6 plus 6 is 0, making everything 0 because of the zero product property. And when x is 2, okay, you could also think of like x minus negative 6. That's how I can get p as negative 6. And this is x minus 2. That's how I can think of 2 as being the other x-intercept. So I could plot that, negative 6 and 2. Now, the axis of symmetry, this is very important, okay? So the axis of symmetry is the midpoint, or the average between p and q. So we take negative 6, we add 2, divide by 2. It's the average of our x-intercepts, or our midpoint. Midpoint, same as the average. So negative 6 plus 2 is negative 4, divided by 2 is negative 2. So the axis of symmetry is that x equals negative 2. I can see this is going to be smack dab in between 2 and negative 6. Okay, so the vertex, I could go ahead and either plug in negative 2 into my equation. F of negative 2 is 1/2 negative 2 plus 6, negative 2 minus 2. I get 1/2 times 4 times negative 4. So it's negative 16 times a half, which is negative 8. Negative 2, negative 8. Or if we wanted to, we could just simply graph we know our axis of symmetry is at x equals negative 2. I'm going to go back to Zoom standard. Trace, plug in negative 2. We get our y coordinate of negative 8. Max or min, we can see it's a minimum value. The minimum value is at y equals negative 8. The domain, all reals, the range. All of my y values are bigger than or equal to negative 8. Graph it a little bit. Negative 2, negative 8. All right, next one is in vertex form. And in vertex form, we talked about it earlier. It's the form of a x minus h squared plus k. The vertex is at h comma k. A tells us if we're opening up or down. A is positive, we're going to open up. Vertex, it's going to be a 3, 3. Okay, you can see like transformation-wise, I'm shifting to the right 3 and then up 3. Axis of symmetry will be through that coordinate of x equals 3. Domain, all reals. Range will be all of our y's that are bigger than or equal to 3. How do I know that? You could graph this again. Just find different points, graph it in your calculator. 1/3 x minus 3 squared plus 3. You got 0, 6. So this is the 0, 6. I know it's going to be 6, 6. Just using our symmetry. You can also confer using your calculator. All right, let's compare this graph to its parent function. What can you determine about the concavity and the width of the graph after the transformation? Well, I can see this is in standard form, ax squared plus bx plus c. I know that a really determines the concavity. We are going to open down And I know it's going to be wider than y equals x squared. If we're between 0 and 1, our y coordinates get smushed down. Like if you're thinking about a graph, this is x squared. Take your y coordinates, multiply them by -2/3, and it gets smushed down so that we would create this wider graph that's opening downward. Wouldn't necessarily the vertex be at the origin, but that's okay. Axis of symmetry, x equals the opposite of b over 2a. We discover it using the quadratic formula. We'll get to our quadratic formula in the next unit. Here, this is ax squared plus bx plus c. So x equals the opposite of b over 2 times a. What are the coordinates of the vertex? Well, I know what the x-coordinate is, the y-coordinate, and I could just plug this into my calculator and graph it, and then plug in -1. But it's easy to do by hand in this. So I got 4 minus 8 plus 5. So -4 plus 5 is 1. So my vertex has to be at -1, 1. Again, you will have your use of your calculator. So graph, and you could also just visually see 4x squared plus 8x plus 5. I know the vertex is going to be at -1. I confirm that. Trace -1. Boom, 1. All right, let's find the vertex to this guy. So x-coordinate of the vertex, opposite of b over 2a. A is 1. I get x equals -8. Now to find the y-coordinate, you can just plug in that -8. It's going to be a little bit more intense though, so we can use our calculator. Might as well just graph and then see. I got y equals x squared plus 16x plus 2. Looks like it's a big graph. I know, like at -8, we're going to have our vertex. It's at -72. Let's just change our window. Let's make sure we can see that vertex. Change my y's. I want to go down to -62. So, oh, there we go. There's my vertex. So trace -8, -62. Okay. Write the non-parent functions in forms indicated. So this is y equals x squared. We want to find the equation for g. Okay, so I know that I have an intercept at -3 and -5. That's why I'm going to put x plus 3 and x plus 5. Okay, so it has to be x plus 3 so that I have an intercept at -3. If I plug in -3, I get 0, everything's 0. One issue is, like, what is a? Works out nicely here, but not always will it work out nicely. I can see the vertex is a point that I know. It's at -4, -1. We need to understand that it's not always going to be a is 1. You should check. You should be plugging in, and this is important, plugging in -4 and -1 to find a. So if I plug in -4 for x and -1 for y, I will get -1 equals, this is -1, this is +1, so this is -1a. So yeah, this confirms that a is 1, and that's nice, but don't always assume, okay? We look at this one, we want vertex form. The vertex is at -3, 2. So immediately I go y equals a, x plus 3, because I'm shifting to the left 3, squared, plus 2. But again, I need to find a, and it's not always going to work out nicely, but in this case it does as well. I can see it's like the same width as my original. That's one way to know that A is 1. Same width. If it's not the same width, and it might not be the same width, taking another point, -2, 1, plug it in to find A. I get 1 equals A. Oh, never mind. A plus 2. A is -1. So yeah, we can kind of tell that it's opening downward rather than upward. But could it be some other value? It could be. Be careful. But we can kind of visually see that it's the same width. These are the same width too. So we know A is going to be the same value, just either positive or negative. All right. Ball is thrown up in the air from a height of 6 feet above the ground with an initial velocity of 40 feet per second. Write an equation to model the ball's height as a function of time. So remember, this is the initial velocity, initial position. So -16t squared plus the initial velocity is 40 feet per second plus the initial position is 6. How many seconds does the ball achieve its maximum height? So the maximum height, we understand this is like a vertex, not a vertex form, a standard form. So we know the x-coordinate of the vertex will be the maximum. You got -b over 2 times a. So -40 over -32 in your calculator. -40 over -32 is going to be after 1.25 seconds. What is the maximum height? So that's going to be the y-coordinate when the x is 1.25, and it's not really an x-coordinate, it's a t-coordinate. So I get my height is -16 times 1.25 squared plus 40 times 1.25 plus 6. And we can do that in the home screen, but let's just go ahead and graph and make sure we're comfortable with graphing of this and looking at it. We're not going to be able to see it very nicely. We're going to have to be able to adjust our windows and see. Zoom standard. Okay, like I don't see the max, but we can see that at 1.25, sorry, trace 1.25. My max is 31. Maybe we want to make sure we can see that it is the max. We can go to a y max of like 34, 35, and yeah, there you go, 1.25. 31. And quickly, a quick reminder, because some of you discovered this and we talked about this, we could find the maximum. Since this is a max, you can find this by pressing max, setting a left bound to the left of the max, setting a right bound to the right of my max, pressing enter, you can see 1.25 and 31. Okay. For 13, I don't want us to worry about using a matrix to find this. I will tell you, if you're given 3 points and you want to find the equation, we can go and do what we learned about with our quadratic regression. So I'm going to come back to this problem 13 after we do problem 14. Okay, so remember 13, we'll come back to it. All right, so here we go. Now we have situations with focus and vertex. So this is the other way to think about parabolas. Remember the equation for our focus and vertex form is y equals 1 over 4p x minus h squared plus k, where p is the distance from our focus to our vertex, and directrix to vertex. Distance from our focus / directrix do the vertex. We also have the equation x equals 1 over 4p. And watch and be careful. Y minus k squared plus h. It's flip-flopped, the h and the k, because of the variables being flip-flopped. So anyways, we look at this guy. I know the vertex is going to be at 2, negative 2. Cool. 2, negative 2. So I got 2, negative 2. That's h and k. So 2, negative 2. Awesome. Now, before I find the focus and directrix, I'm going to find the p-value. So I got negative 1 over 16 equals 1 over 4p. I can see p is going to have to equal 4 or negative 4. I don't really worry about whether it's positive or negative. I'm just going to say p is 4. Now, since this is a negative, I know I'm going to open down. So I open down. I know it's going to be super wide. My focus is going to be 4 units away. 1, 2, 3, 4. So if I have 2, negative 2, this will be negative 3, negative 4, negative 5, negative 6. My focus has to be at 2, negative 6, 4 away. If I look at my directrix, it's got to be 4 up. 1, 2, 3, 4 up. So my directrix is this line, and the directrix is y equals 2. Now, I'm just going to go ahead and sketch this. You can graph this using your calculator, but it's not important. We know it's going to be very much wide and wider than y equals x squared. So just like go ahead and sketch this very wide parabola opening down. As long as you have the correct information, that's really all I care about. Okay, now we're flipping it over. We have x equals y squared. I can see k is going to be negative 1. It's like y minus negative 1, and it's y minus k. H is going to be 3. So my vertex has got to be at 3, negative 1, because I'm adding h, and then I'm subtracting k. All right, now let's find the p-value. I got 1 over 12 equals 1 over 4p. P is going to have to equal 3. Okay, so since p-value is 3, let's start with our vertex, 1, 2, 3, negative 1. I need to go to the right and to the left because this is x equals a y squared. So we know we are going to, since a is positive, we're going to open right. And I'm just going to go ahead and like sketch, something that's opening to the right. That way we understand the focus is going to be the point that is inside the parabola. The directrix will be the one outside. I'm going to go 3 to the right, 1, 2, 3, to the point 6, negative 1, and 3 to the left, 1, 2, 3, to the point 0, negative 1, but really it is a line, and it's an x equals vertical line, x equals 0. Okay, we're going to do the same thing here. Here is my vertex at 3, negative 2. I can see it's 1, 2, 3 away, and 1, 2, 3 away, so I get p is equal to 3. Knowing the equation is y equals 1 over 4p, x minus h squared plus k. Since p is 3, and since my vertex is at 3, negative 2, I will have y equals 1 over, plug in 3, 4 times 3 is 12, x minus 3 squared minus 2. Okay, let's look at this situation. Okay, so I'm opening to the right. I got a vertex at, looks like negative 7, 1. Since I'm opening to the right, I know it's an x equals 1 over 4p, y minus k squared plus h. So vertex, to start with, is negative 7, negative 1, or negative 7, 1. P, this distance has got to be 1. Okay, I'm going to the right one, I'm going to the left one. So I got x equals 1 over 4 times 1. Y minus the k, this is h, this is k. So the k is 1, y minus 1 squared, plus h, plus negative 7. Okay, now let's talk about this quadratic regression. Let's find the equation. Let's figure out the answer. So the table shows the estimated profits from a concert. Write and evaluate a function to determine what the charge per ticket should be to maximize the profit. So ticket price, profit. We can see we're going up and then down. Immediately I know it's not going to be linear because I'm going up and down. Linear would just keep going up, or it'll just keep going down. We can confirm that it's quadratic using our calculator and our tables and stat edit. Okay. Now remember, we can clear off data by going clear, pressing enter. Don't press delete. We want L1 and L2 to stay up there. You want to press clear and then enter to clear your stuff off. And then you're going to enter ticket prices are X. You got 2, 5, 8, 11, 14, 17. We got 2,600, 6,500, 8,600, 8,900, 7,400, 4,100. Okay? And we remember we can go stat calc. Instead of a linear regression, we can try a quadratic regression. L1, L2, calculate, boom. We can see since this R squared is 1, we are perfectly quadratic. Y equals A, that's negative 100, X squared, plus B, 2,000, X, plus C, minus 1,000. Okay, that's my equation. Now I want to see what will maximize my profit. So I want the max Y value. Well, you know, there's different ways to do this. We could literally just find the axis of symmetry. But I just want to show us how, I want to show you guys how we can graph this and be able to visually see it. And maybe we want to find it using our calculator. So obviously if I graph and I'm in student standard, I'm not going to see much. But we can see that, you know, my x's are like 2 to 17. So don't go from negative 10 to 10. Go from like 0 to 20. My y's are like in the thousands, from 2,000 to, you know, 4,000 to 8,000. Why don't we change our y's to like 2,000 to, I don't know, 10,000. We want to be able to see the vertex, and this will give us a good visual understanding of our graph. We can see like, boom, look at that. Maybe we don't pop over there right away. You should understand that you could graph y equals any number to see when you're going to have a specific profit. So let's say like when I just want a profit of $5,000, I can find the intersections to find when I'll have that specific profit. So I will make sure I have a profit of $5,000 if ticket prices are around like $3.67. I'll have another price that's higher to make sure I get a profit of $5,000. But let's not do that. Let's instead find the maximum. We can do second calc max. Go to the left of the max. Go to the right of the max. And we can see it's going to be at this vertex 10, 9,000. So if the ticket price was 10, my profit is going to be 9,000. Okay, that way, like, this will always work in case your things aren't whole numbers. Now let's go back here. Now for you guys, I don't want you to have to do this using a matrix. Instead, we will find if we could plug in these 3 points and do a quadratic regression. If r squared is 1, we will have our correct equation. Negative 2, negative 1, 2. And to the right, I got negative 13, negative 3, negative 9. I'm going to stat calc quad reg, enter, enter, and look, r squared is 1, boom, I got my equation. So that's what I'd want you to do. Y equals negative 3x squared plus 1x plus 1. Do that. All right, please, hope you watched this video. Hope you take this test seriously. We want us to do very, very well in this test because the next unit is going to be tougher. Thank you very much.